the star for the night is Wood Harder. He's going to talk to us about natural language analysis. I'm not going to go read through this because I'm assuming this is why you're here, because you read this somewhere else. My pleasure to introduce Wood. Actually, he's a longtime friend of mine as well. Yep. So thanks, Wood.
Thank you. Okay, so this is about my journey the past 5 years. Been working for this company called Luminoso. I'm not going to make this a sales pitch at all. I'm going to show some graphs that I've done, but I'm hopefully not going to make it a sales pitch. How to analyze text in minutes. How to analyze tons of text in minutes, an incomplete technical overview. Incomplete because there are so many ways to do it, and I keep finding like, oh, let's try this, let's try this, let's try this, let's do all those different things. So, is there anything else I wanted to say? No. So we'll get right into it. Okay. Oh, me and my family. So. I graduated computer science from Chapman. I was one of 3 graduates of Chapman. I'm sure there's a lot more nowadays every year. We had a pretty small program. It's a great program now. I taught adjunct there for a bunch of years. Had a boy and twin girls less than 2 years apart, so I stopped teaching because it got really busy. I started at Hughes doing SAR radar, went to Germany with that program, came back, did undersea stuff, sonar stuff, really interesting, different kind of work. Went to Sun, helped sell workstations there for a long time, got on the Java thing right when it came out, wrote programs in Oak before it was Java, and spoke all over about Java back when it was going. Then I joined and was one of the founders of Game World, went and worked at Chapman with Dr. Fahey for a while. While I was at Sun, I think Dr. Fahey and I set up the first mail server there in Hashinger, bought a Sun, and it was right next to a modem that was hooked to a router, and I think it was on a super rickety table. It was about this size, jostled around a bit, and probably on top of a shoebox or something. I then went to FileNet. IBM bought FileNet, and that's where I met Alan. Worked with Alan for a long time, for a couple years, and was at IBM. Then joined Luminoso. So it's been a good career so far. Let's talk about the problem. So the problem is, what do I do with all that text data? So I've got 300 product. I do a lot of product reviews. Trouble tickets, and analyze audio transcriptions, things like that. The transcriptions lately have been, what do you do with that? This call will be monitored for quality assurance. I'm sure somebody listens to everyone. Wouldn't you like to be that person that listens to every single call? Well, now we have tools that can actually transcribe that and go through and understand on an aggregate level what that data looks like. And does that stuff have any value? I mean, it's interesting kind of stuff. So there's a journey that you go through with analyzing text. The first thing is you got to clean the stuff up. It's a mess. I'm going to talk about that. All these things I'm going to talk about. We're going to talk about, maybe we just do word counting. Maybe I do a tagging party. We'll talk about tagging parties, entity extractors, what they do, vectorization, which is the big deal that I do a lot of with my day job. Using the vectorization to do convolutional neural networks and recurrent neural networks, which I don't do a lot of, but that's where we get these large language models and things like that. We'll talk directly about LLMs, and then I want to talk a little bit about GoFi, like old AI with symbolic AI and things. And if you have any questions, feel free to raise your hand. I have been known to just go off on a wild tangent and throw my slides overboard and talk about something else for a while. So. First things first, this might be, and it might be an eye chart, so hopefully it's not too much. Maybe you should have sat closer. This is kind of the text you get. Tons of HTML in the middle, and what am I going to do with this? The thing on the right here is even worse. I got all these headers. I've got tons of data, and what I really want is, this is the Jules Verne Journey to the Center of the Earth, great book, and you really just want the text. So this would be a CSV file, like a Excel file that I get. And you can see that there's, up here in the upper corner, if you can see that, there's some crazy Unicode in it. And hey, there's all of these metadata fields associated with each of these. I think these are product reviews. This is visual improve excellente. So they got some Spanish in here, Portuguese in here, and what do we do with all of this text? And it could be sitting in a database. There could be, I've processed files like this that have 4 million of these product reviews on travel, TripAdvisor. Okay, we could take those and understand what they mean in 4 million of them. So what you really want is some clean text that is this nice, clean thing that I can feed into my LLM, my language model, my word counter, things like that. So first you have to go through a lot of, in some ways it's a lot of pain. Gathering this data can be hard. You're building scrapers and sometimes you're buying the data from some kind of data company and they have some information for you. But in general, this is the kind of text that you really want to process. And it's sometimes hard to get to. You're writing tons of scripts and just whatever you can do to clean it up and get it into a form that's going to go into whatever it is you choose for your workflow. Some of the tools that I've used a lot, Beautiful Soup is great at taking out that HTML. Whenever I have some HTML, I feed it through that. F2FY is it fixes Unicode issues. This is actually a project out of one of the founders from Luminoso. She just did some amazing stuff. Spacy, we use Spacy for tokenization. I've used it for tokenization. A lot of the samples online are Keras, and there's 50 others that are out there. But those are kind of the main ones that I see a lot of. And we're going to go through and talk about, now we're going to talk about tokenization and what we do for the text from there. So I got all this text. What am I going to do with it? First things first, like this is what we used to do. I am just going to go make a concordance, count all the words, and know where they're at, and do that. And I went on to Stack Overflow and just downloaded somebody else's code. I linked to it here, so hopefully that's enough of a reference. But hey, I'm just going to count this code, and it's got the words of 6 times, example 2 times, use 2 times, a small piece of text. And then I went over to word clouds, and I created a word cloud out of it. That is not uncommon for what people kind of do. Let's just go and, what does it mention, right? And you've got lots of problems with that. So some of the problems are problem not equal to problems. You got probleme not equal to problem. It's a misspelling. You get tons of misspellings. You got FYI is not the same as for your information. It's mentioned the same way. How do we get around that? You really don't want to be counting a, the, y, I, those kinds of things. And the other one is like, I want to go a little farther. How do I know if problem is being used in a positive or negative way? I solved the problem. That's positive, right? That was a really hard problem. That's a negative. So we really want sentiment that is oriented towards the context of the actual verbatim as well. And a lot of systems don't do that. They create, most of the systems out there create a table of, hey, problem's a negative. Let's just make it a negative. And then you end up with all this bias in your data and stuff like that. Blood is always a negative. Nobody wants to see blood, but hey, blood could be saving someone's life, right? So these are things that some of the problems that we see in the general industry. The other one is tagging parties. So you get 10 of your colleagues, you got 10,000 sentences that you have, paragraphs that you have to, and everybody gets to read 100 of them, and then they have an Excel spreadsheet, and you pick 7 columns. I want this column to be about X, and this column, if it's talking about Y and Z, and I just put a check mark by it, and hey, if it's positive, put a little check mark in this column, then we'll go and create some graphs around that kind of stuff. It's a really good way to get your work colleagues to hate you, okay? So, and I created this image on Mid-Journey. So I just love the look on her face, because and this guy too, he's like, now that I have all this data, like what am I possibly gonna do with that? So that was my favorite one. And then you've got this case of, I can take this to an entity extractor. And I used one of these for years. When I was at IBM, we had these entity extractors, and they're great at detecting people and places and events and numbers, social security numbers and phones, and they come back with this giant XML, nowadays JSON, but this really hard to parse kind of stuff, and you really end up with a system that's like, okay, what people use it for? Just find me all this social security numbers in there so I can redact them all, put a little black line over it so I can redact them all, or find me all the email addresses, or What we used it for is scanning. You'd scan it, you'd put it through OCR, and you'd say, hey, I want this person's address. And then you'd have this code that would be like, well, there's 3 addresses on this thing. Which one is it? So the one it picks is the address for the bank, not the address for the user. So you've got all these weird problems with these entity extractors and extracting information about this. They do a little bit of classification, a little bit of emotion, a little bit of sentiment, but a lot of those are just lookups, like I said, just looking up stuff in a table. So, and the other one is they're mostly rule-based. So behind the scenes, they are using a lot of regular expressions. So if you ever want to use one of these and you really like regular expressions, they're like my worst enemy, something I've, every time I have to write one, I'm like, oh, these are terrible. So you end up creating these ontologies with crazy regular expressions to go and find. The third instance of this is, and if you're doing something for a drug company, you have to come up with rules for what is Claritin, what is this, and all those things that might be associated in this data set to understand how to find them within this system. Not my favorite thing. Entity extractors are really hard to work with. At least they have been for me. This would be an example of an entity extractor where I say, please find my credit card here. It gives you a big number and thanks for payment. And then it gives you back this, it used to be XML, nowadays it's JSON. It tells it where it begins and ends. It gives you the text. It tells you it's a bank account number, it's a credit card number. And then from there, you've got, what if there's 6 of them in here? What am I going to do with that data? Okay, that's how I'm going to look at it. In a lot of cases, that is some seriously complicated code as well. All right, so we're going to move into the next way, and we're going to talk about vectorization. This will be the one that I think is the most exciting, and it's part of all of these language models, LLMs, all the stuff that we do. And we'll go back to, take you back to simple vector math. You guys remember this? My kids right now, they're in middle school. They just started middle school, so we're doing the line. Okay, so we're all doing line, and it's just a matter of time before they go vertical and they start doing this plotting on a graph. So right now I'm pretty stuck on the horizontal for my kids' math, but any day now it's going to go into 2 dimensions. And so you see, like, I have a vector, which is this direction, and the big measurement I can do is the dot product, right? The angle between them. How related are these? If it's a big angle, I know they're not related. If it's a small angle, they are. We use the same kind of vectorization in 3D graphics, 2D graphics. We're doing all that kind of stuff. It's the same math. It's really interesting. I taught computer graphics or game development for a bunch of years, and it's the same kind of math in that. We're going to do a lot of matrices and talk about that. And the next step is, what if I have these in 3 dimensions? Okay, so I've got an X, Y, and a Z component, meaning I'm coming in or out of the various view, and I can have 3 different values of measuring this. And then you go and say, well, I can I can create a matrice about these. This is 2 3-dimensional points of 1, 9, minus 13, and X, Y, and Z, and another X, Y, and Z, and I put them in a matrix, and I can measure a lot of that stuff and do a bunch of math around it. And then I can get a 4 by matrix here to do maybe some time, and then you go to, I'm going to add even more dimensionality. I'm going to go up to n. Okay, so I'm going to go, a lot of these vectors are 300 by 300, 900 by 900. They're these giant structures. What does that actually look like in the terms of this relationship between all of these concepts? Because what we're going to end up doing is we're going to take a document and turn it into a bunch of numbers, which I'm going to show next, and we're going to find how related they are by basically doing dot products. And another way to do it, if we could build a model that took that giant vector, this vectorization, this tokenization of the data, and we can feed that through a model and figure out how related they are. Or at the end, figure out, hey, this one is related to this category because I fed in to my model, I fed in a bunch of text that was said, all of these are about calling support, all of these are about billing, all of these texts are about some kind of network issue. And then I can come up with, hey, this is the classification of what these are because I have this vector that has some association between all the ones that I already fed in. I'm going to show you that, but that's what we're doing with a lot of these matrices. And we'll come back to the vectorization, but first we have to figure out how do I make these vectors in that I'm going to use to do this mathematical analysis of my text data. And so this comes right out of this, I don't know, it's a blog post that I really liked. You can go back and read it. It's got, step by step, and I'll show you some of it, step by step in code and how you do this tokenization. So we're going to start with the sentence, there was a warm feeling with the service, and I felt like their guest for a special treat. So we're going to take that sentence, and we're going to feed it through this Keras code, and we're going to create a tokenizer. We're going to say the number of words, the maximum number of words is going to be 5,000. I'm going to fit it to the text, and I'm going to take this is a group of text, a list of text. I'm going to take that sequence here. I'm going to turn that text into a sequence, and you can just run this code. I've run it before. And I can take and then I do the training text and the review text, because when we do, this is a classification system. When I do these classification systems, I create some training data, I create some test data, I create my model, then I take my test data and I feed it through and I say, how well did it do, right? And so I'm trying to build a better and better training data size. But anyways, it returns the tokenizer size, and I'm just going to print the first, remember, I just fed in 1,000 different reviews or whatever. One of those texts was that one that I'm showing you. And then our output is here at the bottom. I'm going to show it in a bigger way right here. So you see that what we got is a token. We turned every word into a number. There's nothing fancy here. And these tokenizers just have a set of this word is this number. And you can see that there was A is number 4. And this is the same in almost all the tokenizers. They're just going to have the most common words, because when you get over here, the is a 1, and where is that? There was a warm feeling. The is a 1, and is a 2, I is a 3. So it's the most common words, the most common concepts have the lowest value. And you can see here, I literally just built a vector, a 1 by, I don't know, I'm going to guess that's about 13 to 16, somewhere in there, vector, right? That's a vector. And what you're going to do is you're going to say, well, I want all my vectors, I want all of my matrices, okay? You didn't create a vector, you created a matrice. All of my matrices to be the same size. So I'm going to pick 300. So the maximum length that I'm going to choose to process on the text is 300. Anything else than that, I am going to just truncate it. And anything shorter than that, I'm going to fill the rest in with zeros. Okay? Not that fancy, but it's the first step in building a lot of this vectorization. The next step gets a lot more complicated. We're going to take this and feed it into an ML model, or we're going to take this and we're going to do some processing to turn it into a vector. And then I'm going to talk, there's different ways of processing these vectors, okay? So we have concept vectors and we have document vectors. They're two related but different things, okay? You saw that in this, let's go back, this right here, I would call this, when I'm going to translate it, this would be a document vector, right? I'm going to understand that the sequence of these words are associated with a document. I'm going to turn it into a vector that is associated with all of these words. These other systems, ConceptNet, which is the founders of my company, this is all open source, so you can go get ConceptNet and put it on your own machine. It's free. And word2vec are very similar, where we're actually going to go and build a vector space around every concept that we have. And so same thing with word2vec. And what do they, so we can just feed text in, and we can feed a word in, and it's going to return one of these vectors. And the vectors will all be related. So we can actually see if I feed in frustrated and disappointed, they're going to be highly related. Whereas I feed in frustrated and joyful, they're not going to be that related. And it's going to be that dot product between those two vectors. So those are the conceptual ones. Then we go and turn these into use other systems. And Luminoso uses on the inside, we use ConceptNet as a starting point. We do some transfer learning, but it does both. It's going to generate both these concept vectors and these document vectors to understand to build out this data and do some of this analysis. Then you come up with the LLMs, and you get these language models that are pre-built on these giant data sets. And you've had a couple of talks here on LLMs before. You've got Hugging Face, you've got OpenAI, you got Llama 2, you've got Claude 2, you've got all these language models that are coming up that can do the vectorization as well. You feed it some text, it's going to return you a document vector. They aren't doing the same kind of concept vectors. They somewhat do it, but hey, you're going to get, they're more oriented towards the document versus the concept vector. So I want you to know there's two different things going on here. Sometimes we talk about vectors in terms of the concepts themselves, and sometimes we talk about them in terms of the documents. And I'm going to show word2vec. I'm not an expert at word2vec, but I kind of went through this so I could understand. I didn't want to use Luminosa to do this, so I wanted to go through the vectorization process as it goes through word2vec, so you could see what that looks like. They take that matrice that was the tokenization. Yes, question?
Yes, on the concept net.
Uh-huh.
The determination of the meaning.
Yes.
Where does it come from?
Yeah.
Does it go to like vocabulary and links, or is it subject to the designer, if you will, a programmer deciding that certain concept of word is related to that extent with another?
Yeah.
How does it basically determine?
We could have a whole 2 evenings on describing how this process works. But the process is they've taken very similar to how LLMs work. They've taken a large data set. I can't remember the exact. I'd have to look it up, but there's a whole bunch of different public data sets that they've used and ferreted out that they've fed into the model that they use to create this concept net language. And it's a knowledge graph. So we're understanding that they've had an automated system to build a knowledge graph of language. It's actually pretty amazing.
The automated system went from Merriam-Webster, the dictionary, and checked the definitions, or it was whoever designed it gave the definitions to provide the concepts?
It's different than that. So I can't speak clearly. I mean, I can talk about it. They see the relationships between the concepts. They're feeding in a set of data that they understand. As they parse it, they understand that this concept becomes related to this concept, or this concept is spoken about in the same way of this. And they're basically building out a giant vector map of the relationship with every concept with every other concept, and that becomes this semantic map of, hey, here are the things that are related. And if you're interested in it, just go and type in some words or phrases into ConceptNet, and you'll see exactly, oh, this is interesting. That concept became related to that concept. It's just how they feed the data in and understand the position, these skipgrams, which are how closely related is each concept to every other concept within the context of how it's being used. And there's a lot of data here.
Mr. Harder?
Yes?
Would you like to take questions during your presentation?
That's fine.
Okay, so if anybody's going to ask questions, raise your hands. If we don't get your question on the mic,
yep.
then the recording is very disjointed.
Oh, sorry about that. I'll repeat the question. So the question was who decides how concepts are related within ConceptNet? Thank you for reminding me to repeat the question. Okay. And again, it's an algorithm. It's a bunch of data, and it's an algorithm. And how do concepts get related in GPT-4? Right? It's an algorithm that somebody's developed to figure that out. But this isn't a neural net. This is actually a connectedness. It's a vector space of how concepts are related. Semantic map. So when I want to do this, when I want to create a vector from a concept, I'm going to use this skipgram. I'm going to iterate over the skipgram. I'm going to generate some training data, and then they're going to use that. It creates these labels and vectors, and you build a model with it, basically. And then you can feed. You've got a vocabulary. and then you can call it with new text, and it'll give you back basically a vector, x, y vector, however big you decided that you wanted that vector to be. Yeah, so you can go through, there's a pretty good tutorial here on how to do, I just linking a bunch of stuff if you ever wanted to do that, but that's kind of how word2vec, it's not straightforward, but it's definitely a way that people are generating these vectors. And we're going to get to the point where we're going to talk about, this stuff is becoming very important, and we're going to talk about how this associates with how we're going to talk to LLMs in the future with our APIs. Yes?
What is a skipgram?
What is a skipgram? Skipgram is how closely related two pieces of, two concepts are within the context of a sentence. So, yeah, you're generating lists of these and they're comparing them, and then now you know how related those two concepts are, so you're creating associations between how related they are, how close are their vector, and you're doing this vectorization based on connectedness between the actual concepts. All right, so I use this thing called Daylight. I said I wouldn't do too much of this, but we do the same thing where you take all this data, you feed it in. It uses ConceptNet on the back end to do transfer learning. It creates a model, and then you can feed it text, or then you can ask anything about the text that you created, and I can do something like, hey, give me the top concepts within this, and it'll return the top concepts, and you can see here where I've got the relevance, how relevant this concept was, how often was it used in this, and then I see this vector. Okay, the vector is a giant piece of text. We use another algorithm to convert the text back into a 300 dimensional vector. Okay, 300 floating point variables, doubles. So that's another way of doing it. It's much simpler, really literally, is feed data in, tell it to go. When it's done, a few minutes later, you can get the vectors out. I can do the same thing with OpenAI. I can call OpenAI with this JSON, or sorry, with this curl command, and say, here's the text I want to get an embedding on, and it's going to return this giant vector. Okay, so I can get these vectors out of every system out there. Depends on what they are. They're not that hard. I mean, this one is computationally intensive. I would say that the way Luminoso does it is much less computationally intensive, and word2vec is about the same. It's not as computationally as expensive as many of the giant large language models. Question in the back? Oh, you can just ask it. I'll repeat it.
Okay. Yeah, with the OpenAI embedding, is it using neural network does it have anything to do with neural network?
Yeah. I mean, they've created this giant neural network, and their does GPT-4 use a neural network to generate this embedding? Yes, it's one giant neural network, and it feeds it through, and it comes back with an embedding.
But embedding, the embedding, does it use GPT? I thought there are two separate technologies.
I don't know for sure. I'm not an expert at that. Oh, does it use GPT or does it use another technology? It might use a different technology on the back end, but I don't think so. I think it returns, it's part of the whole system. It's part of the whole architecture. You can feed it, ask it. I don't know what it does on the back end, but it can return embeddings. Okay? Then you get the relationship between concepts. Once I have these concept vectors, and I didn't do this I did this with the Luminoso way of doing it. I can get the two different concepts. I then unpack them. You remember you saw that string. I unpack them into these floating point variables that are a vector, and I simply do the dot product. And I can understand how related are these concepts. Now these are 300 dimensional vectors. Like, what does that mean? Well, 300 dimensions is how is every concept related to every other concept. And at this point, once I have that dot product, I can understand that typically we say if it's over 60% associated, we say about 60%, then they become associated. Then I've got two concepts that are related. And I'll show you some of those relationships. Yeah.
On the note, let's see, it's not. Okay. On the note of relationships between concepts, I'll give one example of a time I asked ChatGPT a question that intensely dealt with relationships between concepts. So there's this book, Herodotus is the histories, and Herodotus is telling all sorts of stories. Now, there's throughout this book, there's a concept of the vine is used, you know, a couple of different kings use it, and it has a different meaning in each context. It's different and similar. So I asked ChatGPT, you know, to please, you know, based on all the usages of this word in the book, to kind of like tell me what it means based on all the different times it's used in this book. And then when ChatGPT responds to me, I noticed that I knew the answer to the question myself, and so I knew all the times and how it was used in different ones, and I noticed that ChatGPT missed a couple of the different like locations where the word vine is used, and it's like, okay, the word vine was used explicitly, and it completely like missed it. And I've seen this before where a word is used explicitly, and if it's not even picking up where a word is used explicitly, you know, it's not going to be able to find relationships between concepts. Like, why is it making that mistake that I'm seeing?
Well, it's not what it was designed for, right? It was designed to generate text. It was designed to take some input in and continue on. I mean, we started at the point where that whole technology was from a type ahead, where we typed something into a browser bar and it started to finish our sentences. And then we said, okay, well, let's take it even farther and it does some amazing stuff with generation, but we're using it for use cases that it might not be best suited for.
Okay.
Yeah.
Thank you. I appreciate it.
Yeah, no problem. I think they're amazing. But, you know, a lot of this technology is amazing, you know, I mean, but then a lot of it is we're using a computer to do something that, you know, it was never designed to do. It's, I don't know, it's like using a vector processor to do, you know, addition and subtraction or do some kind of other graphic, or that'd be a wrong task, but to do a database, right? You're using a processor that's designed to do tons of calculations per second to do some kind of database. No, we have different applications for different capabilities.
Right.
Yeah. Question.
Yes. My question deals with the determination whether we have a crisp division, basically 60%, that is associations, less than 60%, it is not, or do we have some sort of fuzzy classifier as well that gives us some degree of belonging?
Mm-hmm. Absolutely. Yeah. So if this dot product, so is there a degree of association? Yes. If you come up with you get a 99%, you know, you get this 0.99 association. It's much more highly related than something that is a lesser. So, and I have some examples of some of those numbers that we'll see in pretty soon. But yeah, this dot product is amazing in this case where I've built a vector space around all the concepts of my specific data set, which is different than saying, I'm going to take this text and give it to something that's trained on the world's knowledge. I'm going to get some weird answer because it's not tuned for my data, right? So they're different. I'm doing analysis. I want to know what's in my specific piece of data. I can try to get some giant architecture to do that that's designed to generate text to do that, but it's a different use case. And I think those are great. They're amazing. They're doing amazing things. But it's what is the use case that I started with was I've got a ton of text. Does it have any value to me? Right? Can I get anything out of that? That's where I'm coming from. So it's a different use case. We then take these vector spaces, these vectorizations and these tokenizations, and we use them to create classifiers. Say, hey, here's all the documents that are associated with this term right here. I can feed all those in, train a model, and then I bring some new text in, feed it in the model. It's going to go bing. I think that is billing, right? And it could be right, it could be wrong. It's going to have a percentage of how right and wrong it is. Or we're going to build these recurrent neural networks, which I don't have as much knowledge of how the large language models actually work on the inside. I've done a bunch with the classification models, but not so much on the other side. But we're using the same kind of system to take the text to tokenization, take the text to a vector, and generate these models on the next step. All right, so, and this is the part where I just want to show a little bit of code of how we build these classification models. You can see here, what was it I was going to show here? You can see here that I've created these embeddings These are those vectorizations. I've created these embeddings, and at the end, I end up compiling them in, I say I want to be sequential, I'm extending the dimension, and at the end I create a machine learning model, an ML model, a neural network, whatever you want to call it, of this set of what we'd call the training data on that, and then I'm going to feed that into the actual next step. When I do the classification of it, and again, I'm putting links here. You can go read in detail of what these are if you ever are interested in doing these. Once I have that model, that sequential model, I simply, at the end, I create a vectorization of some kind of text, and I feed it to this extractor, and it's going to return those labels that I gave to the model itself. These are classification models for saying, is this text about X, Y, or Z? And I've built them up with samples of X, samples of Y, samples of Z. I've done all the vectorization and understands how related each of those are. And it'll just come back with, I think it's blah at X%, and it might be Y at, Y%. Okay? So these are the classification models that are out there that we use. Some of the applications of doing this, things that I've been working on for, I didn't work, this is Luminoso. So a vector space can be then translated into three-dimensional space, and we can actually see that AMD, this is an AMD dataset, a CPU dataset, AMD is actually related to, I've picked satisfied, and you can see that I can start to see, I'm going to pick battery life here, and start to see how battery life is related to all the concepts around it. These are not just word clouds anymore. These are all the associations and how related they are mapped into a common space. Yes, question?
Yeah, with this mapping into three-dimensional space, are you using a 3D convolutional neural network, a 2 plus 1D, or is this just a straight 2D that you are then abstracting on the visualization front?
Yeah, this is a similar model to what, it's not a model. This is a similar language model from ConceptNet that we've done transfer learning on a data set that was associated with AMD, and we've built up this giant vector space of how every concept was related within all of these reviews we got around AMD. That said, every concept is given a 300-dimensional vector, and we can map those into a three-dimensional space. And that's what we've done here. And this is common. This is I think this is the kind of view that got Luminoso their initial funding, and it was the initial view, and it's just gone on from there. But the raw data is every concept has a 300-dimensional vector. That's the language model right there. And you saw that earlier, where every concept has a vector. It's embedded in text, and then we can extract out the actual numbers out of it. We can use that same data to understand if this data had metadata associated with it. In this case, the data itself, every review had a rating given to it, 1 to 5 rating. We're talking about Amazon or Walmart or Best Buy ratings. Each one was given a rating. What is driving this up or down? This is an Oculus data set that I went through. And we got, I don't know, there's like 15,000 reviews split between Walmart, Best Buy, and Amazon. And you can see on Oculus, what is driving your scores down? Well, Facebook right there. People were so upset about, Oculus when Meta bought it. Now I've got to have a Facebook account. You can see it's driving your score down by negative 1.47, right? And that's just, but on the other side of it, it's about 1,000 people out of the, I think this was 6,000 reviews. And you can see all the other things, the things that are driving up. People bought it for their grandson. This is the Best Buy. The Best Buy was, I'm going to show you a really cool graph about the differences between the language used in different places. But these are the best, people bought it for their grandson. They really like the interactivity. Other things they don't, battery life is low. They don't like the headset's heavy, the strap gets to you, things like that. So you can start to see when you're reviewing this data, when you're going through it, you don't have to read 5,000 product reviews. I can simply bring it up to something like understanding what is said in the different review categories for 1-star review versus 5-star review. Okay? Over time measurements. You could take that same data and say, how is this changing over time? This is a vitamin gummy data set, and it's super interesting in that you could see these blips right here for melted. If I had this interactivity here, the blips all are Q3. Right in summertime, everybody's complaining that your vitamins are melting. And you can go through this data, and there's 4 different types of vitamins, and you can see that it's only certain ones of the gummy vitamins. These other ones must have a different packaging, and packaging follows this same terms because people are saying, your packaging stinks, you melted my vitamins. You know? So those are some of the capabilities that you can get out of these. I went backwards, sorry. Sentiment. So here's some interesting, you can take that same data and start to understand sentiment. How is it used? And in this case, we've developed a model for understanding sentiment in context. And you can see that the most positive terms, a lot of the positive things are, people really like gaming. I think, what is this one? I think this is still that Oculus one. Oh no, this is the AMD laptop data. But you can see that while fast is 96% of the time people use it in a positive way, 4% of them they don't. And you can see that fast in this case, it got hot very fast. So that's negative. You're using it in a negative way, and it's super fast, and it looks super handsome. So that's somebody using fast in a positive way. When you're doing sentiment, you have to have a better way of understanding sentiment than just using simple words. And this is just built into what I do. But this is I'm not trying to sell this, I'm just trying to explain these are some of the capabilities. Once we got this vectorization, we can understand the relationships between how things are used. There's a lot more going on beyond that of how this model chooses sentiment, but it's one of the things that you can start to do with your text. This is something I built 2 years ago. I started to build out, search enhancement, so the ability to understand and improve and make search more conceptual. This is for a beauty product manufacturer, and they wanted to improve their search results and make it more conceptual. So instead of searching for the specific word, can I search for things that are related to that word as well? And you start to see that, oops, didn't mean to hit that. You start to see that relief here, if I take this is a product description for relief for skin conditions such as eczema. And I just took an excerpt out of that, and I just went through and found each of these concepts. Relief is also associated with relieve, reliever, soreness, alleviate, discomfort, and pain. You see my 6-0, I picked the concepts right there. And then skin is associated with epidermis, cutaneous, and this is just from feeding in, I don't know how many, we had 400,000 beauty product reviews off of Amazon is what we fed in here. And we built this language model around that had how every concept was related to them, and then we could come up with the top relations between concepts and understand which concepts were related. And then we could embed these concepts with the actual search index and say, while you're searching for keywords, also search in this set of keywords because they are related. Now, nowadays, I think the same model we're starting to see is using k-nearest neighbor, and we're using those same vectors. Now we can have a vectorization of every one of these concepts, and we're starting to see that be embedded into the search engines as well. So you can use that text data to actually improve your search, right? So what are the other ways that we can use some of this vectorization of data? This is another, just a second slide of that. We ended up with some of the interesting, here's another product. Exana is an all-natural solution skin condition. So Exana got associated with rosacea and these other products. All natural was wholesome, self-to-use. Irritated skin, aggravated, inflamed. You got lots of different ways of associating different concepts in this space. Going back again to that AMD and Oculus review, you see how the language, and this was put together by a company called MAI. They're a market research company. I've worked with them a bunch. They do some amazing stuff. They came up with this one with that data set that I created, and they found that this is how people that bought through Amazon talk about battery life and technical details. people that bought through Best Buy are like grandparents. They're talking about the games and their grandkids and it's given as a gift. And people that bought through Walmart are talking about getting it set up, having trouble setting it up, and the headset and the strap and things like that. It's just an interesting kind of different way of looking at it. This metadata can be really valuable to understand the differences of how people talk in different key aspects of it. This is a system I did, and we haven't used it for anything, but I took all the sentiment data across a transcript, a couple of video transcripts, and understood how, and this was somebody doing a review of what is that, Steam Deck, and went through and understood that, hey, when he's in this position, he's negative, and we can do a lot more stuff around, associated with the text and colorizing the text, but we can understand how sentiment changes over time with that. Last year, I built a bias detection algorithm, so we could actually we took like 5,000 emails, put a couple of them that had a bunch of bias in it, where they're talking bad about somebody, and those 16. And this is kind of the algorithm of what we did. We found low prevalence concepts that had negative sentiment, and we went and looked at those. We got 14 documents tagged out of 5,998. 2 of them were our controlled documents, so they were the top. They were like, yeah, this is pretty bad. And then 12 were false positives, and some of those were also interesting. I don't know if I put that one in. Yeah, this is the interesting false positives. This is one of my favorite parts of this. That mold became a biased concept, and it's really interesting that there was dark spots in my basement. So this is the one that got tagged. Of course, nobody likes mold. We're all biased against mold, right? So it found this false positive, which was pretty cool in that data set. I was pretty happy with that. I've used it for label generation. So when you create those classification engines, you have to create your labels. Tons of data comes in, but it's not labeled. And then people are like, what do I do to label my data? So I wrote this script to go through, and you simply create your concepts. These are greetings and wrap-ups. They're things about, and we went through and looked at these and just looked at the data and said, oh, when people are talking about greetings, they're talking about these people and thank you, goodbye. And then when they talk about inventory, they're talking about available stock. So we came up with a bunch of concepts of how people talked when they were talking about this label. We then use the tools to search for those documents, those, in this case, they were transcripts, those specific transcripts that were, the specific points in the transcript where they were using these concepts. And then we're able to tag those. And then anything that was overlapping, we just threw it out. And so you get these very specific sets of data that are associated with each of these types of concepts. So we can use it to really, if you ever have an issue where you need labeled data, you can create it with this way as well.
Question.
Yeah.
So it seems like this is a supervised training, right? So if we have a bunch of data, then that means we kind of need to label every single sentence.
Yep. Yeah, if you're building a supervised classifier, some of the hardest stuff. It seems so. The question was, I don't know if it's a question, but this seems like this is for building labeled data sets. Is that a?
Yeah. It seems like probably if at the beginning I thought sometimes large language model is easier sometimes because you can just have the model and understand something. Right? But for this case, I guess you need to really have someone to tag or label it.
Yeah. Yeah, so labeling data is typically a hand-done, people are reading through it, very similar to the tagging party model where you have to go through and label all your data. It's kind of really annoying. And so I developed a system that is pretty good at labeling data if you want to ever use it. Does that answer your question?
Yeah.
I'm going to jump into the last section. I got about 10 more minutes. We'll be fine. LLMs and vectorization. So this is one of my favorite quotes recently. It was in Wired Magazine. And I got a subscription to Wired Magazine for like a couple bucks, and I decided to read it again. But this was from Christopher Nolan in one of the last issues I got. And it just says, growth in terms of AI, in terms of weapon systems, and the problems that they are going to create have been around for a long time. Few journals bothered to write about it. Now that there's a chatbot that can write an article for a local newspaper, it's big news, and it's the worst thing that it could ever happen. So I just really enjoyed that quote right there, because we've had a lot of months of people saying these LLMs are going to be the end of the world. Oh my gosh, they're going to come get us. But it's really just the journalists that they're after. So. So the big issue with LLMs that we're starting to see, and this is a way we can use vectorization to approach this problem, is this context window. Typically, context windows are 4K to 100K. I think the biggest one is Claude 2 right now with maybe 40 to 60K, maybe up to 100K, but we're not seeing much more than that. It's not a lot of data. We're talking, Game Boy kind of, and it's going to evolve over time. But right now, we're starting to see that this context window is how people want to talk to them. So let's talk about context windows for a minute. And I want to talk about this article right here. It's amazing. You should go and click this one and go and get it. It's an article about ChatGPT and Python, how to simulate a Linux terminal with just a few lines of code. And I love this thing. It's so neat. I have not tried it, so I'm hoping that this isn't just a joke and somebody created something and faked it. Like when people first started to talk about ChatGPT, oh my gosh, it's sentient and stuff like that. I don't think it is, but I'm hoping that it's not. So I haven't actually tried it, but I do love this piece of code. So here is my system content that I pass to the API says, I want you to act like a Linux terminal. I will type commands and you will reply to what I do with what a terminal would show. I want you to reply with the terminal output inside unique code block and nothing else. Do not write explanations. Do not write commands unless I instruct you to do so. When I need to tell you something in English, I'll do so by putting it inside curly brackets, blah, blah, blah. And then you see I just got a simple while loop. This is a super simple program. I tell it which model I'm going to use, GPT 3.5, and then I pass that impersonated role based on this command history. So the last thing I type. So the first time through this, it's going to be blank. Just telling it, hey, behave like you're a Linux terminal. And then the user is going to type in, we got some input from the user, it says input command, and we're going to pass that as the user content. And then it's going to print a message, and it's going to add what I just typed to that command history. That's my context window, okay? So it can be 4K in this case, right? It's pretty small, but in this case, the commands aren't that long. But the cool thing is, hopefully you can see this, is the first thing they type in, and it's in dark green, so it might be hard to see, is pwd. And you can see that it comes back with /home/user. I mean, okay, that's pretty cool, right? And then I type cd documents, and then it doesn't put anything out. There's no output to cd documents. And then you type in ls, and it comes up with a list of crazy files. Like, okay, that's kind of cool. And then you type in, I'm having trouble seeing that. I want to touch a new file.txt, which creates a file in Linux command line, and it doesn't come back with anything, right? Because it doesn't do anything. I've done this 100 times. And then I'm going to type ls, and sure enough, that file that I just typed exists in this list right here, right? So. And so this context window keeps going, and then they do this other one, which is, top. They do top, which is measuring, like, tell me what's going on with the CPU. It comes up with a bunch of processes that are cool here. This would be so fun to hook up to some server and put it out on the external network and have some hacker come in and like, oh, I'm in, yeah, I got something good, and just have them go running in circles for a while. So ifconfig returns something. It just keeps going. But then you run into this issue. Right here is this context window size. Okay, so if I typed in 3,000 commands, something's going to fall off the end. So I can't ask these large language models. If I've got 5,000 product reviews, I can't give them to a large language model and have them understand them. And therein lies one of the deficiencies that people are trying to get around. I want to talk about one of the ways that I've been working with lately. We're building this project on the side, not on the side, but it's one of the things that we've been building. And there's ways around this context window. It uses the same vectorization. So this is another. There should be a link down here to the article. I'll put it back. Anyway, this came from somebody else. I got to reference them there. So this is the overall architecture for getting around this. And so you have your large language model, you have a vector database, and you have this thing called, some people are calling it long chain, but I like LangChain better, but I don't know, long chain. This application called long chain. Somebody types in something and they're saying the best running shoes. I've got a whole bunch of data that's about running shoes. I've done the vectorization on that and I've stored it into Pinecone. And what I'm going to do, because remember, I want all of my existing data to go along with that system thing that I said, hey, I'm going to ask you a question about running shoes. We've got this little data set over here that talks about running shoes. We want you to kind of understand that as well and kind of respond with some of that. So what happens here is that we go through and LongChain is going to call Pinecone, and well, Pinecone is a vector data store, and it's going to say, hey, give me everything that's related to this sentence of best running shoes, and it gives you back some X number of documents. If it's over that, you get something back that's just in that context window that I can feed into the large, to the LLM along with this query, and now it's using that data. So it's a way of using, and this is all super right on the edge of where I'm starting to push, but this is the architecture for getting, one of the ways that we're starting to see people getting around these issues with large language models. So again, this vectorization is really, really important, and it's important across all of these disciplines, not just in order to analyze large pieces of text, but to do that. Past, present, and future, I'm going to be done in a second. I just wanted to go back and talk about GoFi, good old-fashioned AI, because I really feel like this is where I started in the whole process of creating these predicate logic systems where I create a logic sequence that for any fox, there is a snail such that X is, the fox is faster than Y. Okay, so you create these. And I just picked this off of this. I just went and did some searching and found somebody that was doing this predicate logic. And I took a class in this when I was going to school. And this was the kind of stuff. At that time, there was nobody doing those neural networks. And nowadays, you see nobody doing this stuff, and you see everybody doing the neural networks. And I have this, I'm just getting to the point where there is an issue with understanding. These large language models don't understand anything. They just spit out a continuation of what you came up with. But if we really want to understand that, we really have to start thinking about how do we pair these neural models with these symbolic models and these rules and pair that together. I don't know the answer to that. I'm just saying I think that's where you can see a lot of the wheels starting to go in that direction of how do we pair these two, because they really are different systems, and one is kind of a understanding decision system, and one of them is kind of a text communication system, or coming I don't know. I don't know what I was going to say about this. But there are these companies that are doing old symbolic. SICK is one of them. They're also an early investor in Luminoso because of the way that the ConceptNet created these, what was the word for it? Rule-based understanding of language. Bunch of these companies here. But we're, and this is my opinion, we're going to need to combine these two for computers to really understand this stuff. Because right now, the large language models, they come back with some pretty amazing stuff, but when we start to ask them really detailed questions, they're kind of like, yeah, that's not really what, I'm not that smart, right? So, and if you fed that question into one of these symbolic AI, how is Vine used in these? Well, there's a bunch of rules that Vine is this in that part, and Vine is this in that part, and Vine is this in that part, and it's going to come back with the symbolic system that says, yeah, it's these three separate things, and it's going to be a really simple response to that. So there is a way to really combine these two, and I think we, as an industry, need to start looking at both instead of, for years, if you go back and read the stories of how neural networks just got shoved aside and didn't get any research money, and the symbolic AI guys got all the money and all the grants for a bunch of years, and now you're seeing it going the opposite way. We got all the money, you guys get none. I think we got to start looking at it from both directions. Again, the idea was that there's this semantic network in ConceptNet. One of the reasons why I've stayed at Luminoso for so long, I've been there 5 years. That's all, for me, I never stayed anywhere less than 2, but I've been there. I really think there is something going on with how this data is laid out and how the large language models are laid out, that there's a combination of things that we can do. And I'm just pondering that. At some point, I'm going to figure out how to combine those two. One sec. So in summary, we talked about text processing, we talked about the vectorization process, applications of vectorization, neural networks, LLM, symbolic AI, and I really hope that you enjoyed the talk, and I'm more than willing to talk to you on LinkedIn or give me your number or whatever, and we can continue the conversation. So thank you very much.
Hey, thanks, Wood. If you're up for Q&A, we'll have some minutes to do that. Anybody have any questions? Yeah.
So in terms of the vectorization and the dimensionality, is there some sorting process so that you get all the conjunctions and personal pronouns on one side and all the other types of words on another side? Because I don't understand how the dot product would work if all the words were scrambled around.
Yeah. Well, a lot of those, so is there something to do with, I missed the word, pronouns and all those conjunctions and things like that? The way I know that it's processed, a lot of that gets thrown out. We're talking about stop words. Of is a stop word, the is a stop word, I is a stop word. We just throw those out. We don't even use them. And we're just measuring the bigger concepts and how they're related. And the relationship exists between how close they're used in a sentence. A lot of it's parlor trick. Even the LLM stuff is a lot of parlor trick. We're just, there's not a lot of understanding there. But once we do that analysis, we can actually get measurable results and measurable, scientifically valid results out of how these things are related. Yeah.
Hi, I have a question.
Mm-hmm.
So like on the LLM side, we are recently seeing that there are domain trained LLMs like, MedPalm, which is trained on medical. Is there a similar concept in ConceptNet?
Yeah, so, well, in the LLMs, we're seeing domain-specific LLMs. In ConceptNet, at least ConceptNet itself is a single domain. It's a pretty broad domain. It's not nearly, I think we need to go back and make a much larger version of ConceptNet, much like the LLMs have done. But the next step, if you want domain-specific, that's what we've done at Luminoso, is you can bring your own data, create a domain-specific. And we've done things like drug trials, exactly. I can't even imagine building an ontology for some of these drugs, just because I've had to build these ontologies before, and it would just drive you nuts. With Luminoso, you feed this data in, it starts to understand acronyms and misspellings, and starts to get the associations together. This word was used like this, and this one was used like this, therefore they're related. It's magic in some ways. But yeah, that's how we would build a domain specific. And anybody's welcome to go download ConceptNet and build their own, generate their own association space based on a specific domain. But that's what we do. Yeah.
Are you able to comment on the vectorization process for foreign language like Chinese, Japanese, Korean?
Yeah, so the comment on the vectorization process of other languages. So we've done it, we've split it out. Like you have right now, the way most of it works is you're going to pick your language ahead of time. So we do 14 languages, but you can't have an English language mixed with Portuguese, with some other language, Spanish. When we do that, you'll see it immediately in the data. There's a huge association, a blob on one side that has the Spanish and then the English. They pull each other apart. We specifically just do one language at a time, and it's a hard problem. I think. I'm not sure that it needs to be solved right now. We haven't had a lot of customers desiring that. We have a lot of data that comes through, and I've got filters, another one, that will go through and detect languages and split a data set and throw out the things, or split them into their various languages. So I've used a bunch of different, I've used Spacey to try to detect it, ConceptNet to try to detect it. The language detection stuff kind of sucks, but yeah, it's hard. It's a hard problem.
You want?
Thank you. Actually, I have a question related to the generative text perspective from ConceptNet. Is it capable of generating text?
Is ConceptNet capable of generating text? And the answer is it was never designed to. I think there are capabilities that I think there's possibility to use that, and the quickness of how quickly we can generate our association space, our language model, really could vie for. I mean, how long does it take to generate the language space for ChatGPT or GPT-4? I mean, we're talking we're talking, some serious electricity, right? And I think there's an opportunity for the different semantic models to be better at generating language for specific topics. So, but it's not something it would take. It would take not me. Like, it would take someone a lot that's more linguistically and scientifically smart than me. So I'm just keep going at it until it works. I don't know what's going on. I'm using the backhoe, but I don't know how the hydraulics work on it. Yeah, I know there's some hydraulics on there, but I just know how to dig holes. So sorry.
And the ConceptNet, trying to understand the difference between the self-attention-based transformer neural network versus ConceptNet. So what is the crux that ConceptNet is able to relate all these other than vector? Is there anything else?
I mean, they are completely different ways. ConceptNet and large language model are just completely different ways. And they have different applications of how we're going to understand data. And we're using ConceptNet to understand the connectedness between concepts. We're not using it to generate text. We're not using it for anything other than what we do. But it does have this semantic capability that I think deserves and is, and everybody I've worked with at this company is like, yeah, there's just so much here of possibility. It's just a matter of time before. I don't know. I think it's a good space that we're in right now. But again, the way that system works is just different. I don't know I don't know how else to describe it. I tried to describe it, but it's hard, complicated. But it pairs more likely. I think it's much more associated with the GoFi system, and I'd love to. I did a bunch of Prolog when I was a student of this language coding in logic, and taking those semantic trees and pushing them into a way to query some of that data in different ways is always interested me, but I mean, there's only so much time in the day and I have regular work to do. So I think there's capabilities there that are interesting. Yeah.
I have two questions. One question deals with the diagram that you showed for how the different stores, if you will, the buyers in different stores tended to make the judgment, if you will, or
This one?
this one.
Yeah, it's a great view. MAI
Now,
again, it's a great company that does
The
this.
question is the extraction of data for the market segmentation and understanding what are the customers or what is the customer base. Has that been done or looked at?
Yeah, so what we did is each review has a piece of metadata associated with what store they actually left the review on. And so you can use that to filter and say, tell me about what this group, the top concepts in this group that bought from Best Buy. I want to know the top concepts there. I want to know the top concepts in the way people from Walmart talked, and I want to know the top concepts around the people from Best Buy talked. And then and this is not one of my graphs, but then use that to map that into this domain space.
But from that, the information is, what can we figure out about the customer base? Is it the uniform across all of the stores, or are there different customer bases?
Different customer bases just within Best Buy itself?
But like between Amazon and Best Buy. do we have different buyers, different groups of buyers, or buyers going to Best Buy tend to be of such and such characteristic, as opposed to people who shop on Amazon or Walmart? Or is it
so the-
insufficient to draw that data out, or conclusions or correlation?
Yeah, I mean, there, you'd have to have some data to correlate with. I mean, in this case, we just know this is how the different people talk. So.
Okay. And the second question deals with the difference between the respective approaches. One could be characterized as an black box, which is basically what we have here, the language, large language models and similar. The other one that you refer to is finding the relationships that basically tells the rules. And it's more like a white box type of approach, because we can see what's going on inside, whereas here we cannot see what is going inside. Now, a little bit of a philosophical question is, in your experience, did you see the influence, if you will, of energy that needs to be spent for one approach or the other that influenced the specific choices of where the researchers went to, where the money went to? And that energy may be the time, it may be the intellectual level, or whatever measurement. What kind of feeling did you get in that area?
I'm not sure I understand that question. So,
If you were to spend certain,
if one is to spend certain amount of energy for this approach or that approach,
yeah, so...
and you have the solution, and then you get a point where you can go no further and say, hey, wait a moment, let's go and switch to another approach, maybe it's easier.
Right.
Or,
Yeah,
or
and I
it's
think
faster or something like that. And certain point you say, well, you know what? Yes, it's easy to do it, but I don't understand it. Maybe we should go back to and take a different measure, different energy measure.
Right. And I think, so talking about energy measurement, I think we're starting to see that in some of the large language models. Some of the things you want to do with a large language model. I mean, they're computationally super expensive. I mean, if I'm going to load Llama 2 onto my own hardware, I got to have some pretty darn expensive hardware to put that on. And the other thing is it's pretty slow. I did a project recently where I was sending these text verbatims to OpenAI GPT-4, and we're talking 2 seconds a response. And so this data set that had 1,500 verbatims took, and then it keeps responding like, I'm too busy, try again, I'm too busy. And then it goes to timeout, and then that one took like 5 minutes because it just sat there for 5 minutes, and I've got to have this code that double checks like, hey, did you respond or not? So we're talking about something that's computationally expensive. Right now, I'm sure they're going to solve this kind of stuff. It's slow and it doesn't respond well. And then you've got other, can I get better results out of something that's using a much smaller piece of data? And so at that point, I would choose Luminoso to generate, or one of these other systems to generate my vectors, because I can use those for any kind of search. I would use something else that was much computationally and much faster to generate to do that side of it. So I think you're going to find that, yeah, there's this trade-off of how fast is something and how much. At some point, we're going to have to pay the piper on. This stuff's going to be pretty expensive to start calling these. If we start making, what's the next step in this large language model, and how do we make that faster? Because it really looks like we're getting to the point where just throwing more hardware at it is kind of we're running out of room here. I mean, at least, you put it next to a dam that's, always generating a lot of electricity or something like that, but still not free. Yeah.
All right, with that,
Thank you.
maybe one last question?
Your diagram with LangChain,
Yeah. It wasn't mine, but yeah, I'll put the link into it.
from
Yep.
an architectural standpoint, do you think that, or I should say, how far away are we from being able to plug in something like Zookeeper and take in streaming text into an LLM and, have it in real time, predict and post?
Okay, so the question is how far are we from being able to take in Zookeeper, which I don't know what that is, apologize, and take in streaming data and feed it into an LLM and get responses out of it?
Streaming data. If we can
Yeah.
stream data in, maybe do a couple of things in Pipe, but essentially just, get streaming data into, so kind of replace your document stores
Yep.
with streaming data.
Yeah. Well, I mean, this side of it, where I've got the best running shoes of 20, that's the streaming data we're going to start feeding in. You still have to have pre-trained data of this is the data that I've associated with this space that I'm going to feed into my long chain kind of side of it. Real time, I don't know. I mean, I just looked at how I kind of set up precursor to Llama 2. Can't remember what it was, but I set up one of those in AWS, and that server was going to be just expensive, really expensive. So I'm not sure that we're seeing anything that's going to be, at least for me, computationally affordable anytime soon, because these things are just going to get bigger and bigger and require more and more hardware. So I wouldn't want to stream this data through a large language model right now, based on my experience the last couple of weeks of trying to get data through GPT. But I'm not sure that that's what this was ever. Again, is that the right architecture for building this kind of system? And what kind of result do you want out of this? Out of the stream data. What are you trying to get out of the stream data? There might be a better solution, and if and that's something you'd have to just discuss and try to come up with an architecture that's going to work. If the large language model is going to work, if you can get it to meet your time constraints of this fast streaming data, then yeah, and it falls within your cost window, then yeah. But at some point, if that is not going to become economically viable, then you have to find a different architecture. And that's where I would come in, and you just keep hammering until you find the right way. And it took a while to get to this, for me to get to this architecture. I mean, I had this idea I've been toying with back in, I think I looked it up like April. I did some of the early work to this, and then it's been since then like, how do I get around this context window? I've got this context window problem. I've got this and then I've just been reading. How do I get around this and then I found this. I'm like, okay, that's where I get around this. I can partially get around this context window. So you just got to keep hammering away till the architecture actually is going to work, or it's going to be economically viable. If this doesn't work, then I'm still thinking about like, how else am I going to do that? And the vendors of these large language models, I mean, context window is what they're all working on now. I mean, I think that's a big topic of what they're working on. Yeah.
So Wood,
Yes. Thank you.
love to, on behalf of OCACM, thank you for giving up your evening to
Thank you.
share your insights
No
with
problem.
all these different text processing
Thank you.
approaches. And this
Oh.
is just a token of appreciation
Thank you very much.
for helping us out and providing this talk.